Good morning, class. This is our first lesson on the course titled Trigonometry, and the course code is EBS 169J. I hope we are all level 100 students, and we are in the semester 2. Our first lesson talks about radian measure of angles. Another name for radian measure is the circular measure. By the end of this lesson, we should be able to define radian measure or circular measure. 2, find the relationship between degree measure and radian measure. 3, we should be able to convert angles in radians to degrees. And the last one, to convert angles in degrees to radians. Radian measure of angles, or the circular measure. Now, angles are usually measured in degrees. That is what we know. And it is subdivided into minutes or decimal parts. So if we take our mathematical set, we can find an instrument in it called a protractor. And that is what we use in measuring angles. So that is what we are trying to say. We must note that a right angle is the same as 90 degrees. And 60 minutes is the same as a degree. Therefore, 60 seconds will be equal to 1 minute. The choice of 360 degrees for one complete revolution dates from the system of counting used in ancient Babylonia. Another system used for measuring angles is the radian or circular measure. And that is what we are going to talk of today. Now, by definition, a radian or circular measure, into brackets, ARD, we are using ARD as radian. Or if you see theta exponent C, because we said circular is the same as radian, we can also use it as our symbol. It's defined as the angle subtended at the center of a circle by the length of an arc equal to the radius of the circle. If you look at the diagram below, we have a circle whose center is O, and the radius, we are using R for the radius. Now, per our definition, we said the radius and the length of the arc are the same. So it means that the length of the arc AB is also R. The space in between the two radii is what you are calling 1 radian. Let us now find the difference between, or the relationship between, degree and radian measure. If the length of the arc from our diagram AB is 1 unit and the radius is also 1 unit, then the size of angle AOB is 1 radian. Let us note that if you substitute radius as 1 into the circumference of a circle, which you know that is 2 pi r, then C will be equal to 2 pi times 1. And 2 pi times 1 will give us 2 pi. But we know that 2 pi is the same as 360 degrees. Hence, 2 pi radians is equal to 360 degrees. Now, if you divide this through by 2, then 2 pi radians divided by 2 will be left with pi radians, and 360 degrees divided by 2 will give us 180 degrees, which brings about another equation. Therefore, pi radians is equal to 180 degrees, or pi exponent c is equal to 180 degrees and its equivalence. Now, when I say and its equivalence, it means that we can have more of these equations that are the same. For example, if I want 1 degree, then I can represent it by pi radians over 180 degrees, and so on and so forth. Now, this pi radians is equal to 180 degrees, and its equivalence can be used to convert angles in degrees to radians and angles in radians to degrees. So let us try our hands on some of them. Example 1. Convert the following angles in radians to degrees. A. 3/5 pi radians. B. 5/9 pi radians. C. 21/5 pi radians. And D. 3/4 pi radians. So let us all go through how it is being done. Now, if we take A into consideration, we will take our equivalent, and we said that pi radians is equal to 180 degrees. Then 3/5 pi radians will be equal to what? We know that we can use ratio and proportion, or the idea of what we usually say: if less, more, divide. Now, if you use if less, more, divide, then 3/5 is less than pi. Therefore, we have 3/5 pi radians divided by pi radians times 180 degrees. Pi radians is common to the numerator and the denominator, so they will go off, and it will be left with 3/5 times 180. Further simplification can give us 5 will go into itself 1, and 5 will go into 180, 36. So we multiply 3 by 36 and to give us 108 degrees. So you see, we have changed 3/5 pi radians into 108 degrees. Good. I hope we are following it. Now let us take B. We have to change 5/9 pi radians into degrees. So we still use the same equation that says that pi radian is equal to 180 degrees. Then 5/9 pi radians will be equal to what in degrees? 5/9 is also less than 1. Therefore, if less, more will divide. This will also give us 5/9 pi radians over pi radian times 180 degrees. The pi radians will take care of themselves. and it will be left with 5/9 times 180 degrees. 9 will go into itself 1, and to go into 180, 20. Therefore, 5 times 20 will give us 100 degrees. The third one, that is C. We are converting 21/5 pi radians into degrees. So if pi radians is also equal to 180 degrees, then 21/5 will be equal to 21 pi radians over 5 divided by pi radians multiplied by 180 degrees. Now, 21/5 times 180. 5 will go into itself 1, and we have said already that 5 will go into 180, 36. So we multiply 21 by 36, and to give us 756 degrees. The last one, we are changing 3/4 pi radians into degrees. So if pi radians is equal to 180 degrees, then 3/4 pi radians will be equal to what? So if less, more, we'll still divide. So 3/4 pi radians divided by pi radians multiplied by 180 degrees. And pi radians will take care of themselves. So it will be left with 3/4 times 180 degrees. 4 will go into itself 1, and to go into 180, 45. So it will be left with 3 times 45, and that will give us 105. Good. I hope we are following. Now, example 2. This time we are going to convert from degrees to radians. So, for example, convert the following angles in degrees to radians. A, 90 degrees. B, 54 degrees. C, 270 degrees. And D, 330 degrees. Now let us take A. Now if 180 degrees is equal to pi radians, then 90 degrees will be equal to what? So we still use 90 degrees is less than 180. Therefore, if less, more will divide. Now this gives us 90 degrees over 180 degrees times pi radians. 90 will go into itself 1, and to go into 180, 2, leaving us 1/2 times pi radian. And 1/2 times pi radians will give us pi radians on 2. So we have also been able to change from degrees to pi radians. The next example, B. If 180 degrees is also equal to pi radians, then if you want to change 54 degrees to pi radians, then we also say if less, more, divide. Therefore, we have 54 degrees over or divided by 180 degrees times pi radians. Now, 54 will go into itself, 18 will go into 54, 3, and 18 will go into 180, 10, leaving us 3/10 times pi radians. And if we multiply 3/10 by pi radians, it will give us 3/10 pi radians. 270 degrees. Now, if 180 degrees is equal to pi radians, then 270 degrees will be equal to what? This time, 270 degrees is more than 180 degrees. Therefore, we use the idea of if more, less, divide. So we have 270 degrees divided by 180 degrees times our pi radians. Now, the zeros will go into each other, or we can say 100 will go into it 27 and to go into it 118. Now this reduces it to 27 over 18 times pi c. Further simplification, we have 9 will go into 27, 3, and now we'll go into 18, 2 times pi radians. And this will be left with 3 halves times pi radians. And this will give us 3 on 2 pi radians. Then we have D, 330 degrees. So if 180 degrees is equal to pi radians, then 330 degrees will be equal to what? In radians. This time, 330 degrees is also more than 180 degrees. Therefore, if more, less, divide. And this will give us 330 degrees divided by 180 degrees times pi radians. Now, if you reduce it, then you have 33 on 18. It means you have divided through by 10 and 10 times pi radians. Now, we can still reduce it. If we still reduce it, then we will have 3 will go into 33, 11, and 3 will go into 18, 6 times pi radians, which will leave us an answer 11/6 pi radians. In summary, that is to say, what we have learned so far, we talked of a radian, and I hope we can now or all define radians. We said a radian or a circular measure is defined as the angle subtended at the center of a circle by the length of an arc equal to the radius of the circle. We also learned that 2 pi radians is equal to 360 degrees. Pi radians is the same as 180 degrees. And the formula 180 degrees is equal to pi radians, and its equivalence can be used to convert radian measure to degrees and vice versa. Now, let us take these as our self-assessment to check whether we understood the presentation or not. Example 1. Let us convert the following angles in degrees to radians. We have A, 200 degrees, B, 135 degrees, C, 45 degrees, and D, 200 degrees. 2. Convert the following angles in radians to degrees. I hope we can all do it. For me to check on you whether you have done it or not, I hope you give me feedback on Wednesday So at least you have 2 days to finish with this self-assessment. If you still don't understand any part of the presentation, you can talk to me on our WhatsApp group or the Google Classroom or any of the tools that has been given to the school and you as well. So this is the end of lesson 1. Thank you very much and hope to see you again. Bye-bye.